Number 4. The resistance of the field coils of a 400 kilowatt 230 volt shunt generator is measured after the machine has been standing for some time in a room temperature of which is 21 degrees Celsius and is found to be 14.6 ohms. After the generator has been in operation for 3 hours, the resistance is again measured and found to be 16.2 ohms. So, determine the average temperature of coil after 3 hours. B, the temperature rise. Okay. So, with this problem, we'll start again with the formula. R2, final temperature over initial temperature is equal to 1 plus the temperature coefficient, temperature final, minus temperature initial. So, based on the problem, did he include the temperature coefficient? So, it's none. So, it's not even mentioned. So, we have to determine our temperature coefficient. So, let's assume it's a copper, made of copper. So, let's determine our temperature coefficient with respect to our initial temperature, which is 21. Okay? So, doing that, our temperature coefficient is equal to 1 all over your T. Your T is equal to 234.5. 234.5 plus 21. This is equal to 0.039 So I'm going to save this to my alpha A. Okay, store at alpha A. Okay, moving on. So based on the problem, the initial resistance is found to be 14. So that is your R1. After the generator has been in operation for 3 hours, the resistance is again measured and found to be 16.2. So that is your R2. So here in our formula, please refer to our previous problem. So our formula here is R2 over R1 is equal to 1 plus our temperature coefficient at 21 times your final temperature, which is that is unknown for your letter A, required average temperature of coil after 3 hours. That is your operating temperature or your final temperature. Doing that, we can determine our operating temperature. So, what is the value of our, this is your R1 and this is your R2. Okay, so substituting the given parameters, so 16.2 ohms all over the 14.6 ohms is equal to 1 plus your temperature coefficient, which I save it to alpha A, and your unknown, your operating temperature. So finally, your T2 is equal to your temperature is equal to 28 degrees Celsius. Now, for our, so we already determined A. Now, we are asked to determine the temperature rise for our generator. So, initially, it was, that is the change of T, or that is your final temperature minus your initial temperature. Okay, so what is our final temperature? That is 28. Our initial temperature, so that is 21. So change of T or our delta T is equal to 7 degrees Celsius. So the temperature rise is 7 degrees Celsius. It rise from 21 going to 28. So this is our answer for B, and this is our answer for A.